Let's discuss how we would use this ordinal analysis crossed orderings procedure when we do not have an a priori prediction with regard to the ordinal pattern. So we've been using this small data set where we have two groups, experimental versus control, and we have reaction times. And in previous videos, we had the a priori prediction that the experimental reaction times would be lower than the control reaction times. And so we would just set up our analyses. We'd move time over as the first ordering, and then we would move group over as the second ordering. We'd go to define pattern. And again, I'm going to magnify this just so we can see it clearly. And then we would set the experimental as being expected to be lower than the control individuals. But again, let's say that we're not sure what to predict here. We do not have an a priori prediction. Then what can we do in the software to run this analysis? Well, one thing we can do is select the medians radio button here, and it will compute the medians then and plot those in the pattern. So we can see with the medians then it suggests that's the pattern to go with, the ordinal pattern. But for my money, I'd prefer to just go ahead and look at the data rather than even relying on these medians. So let's cancel out of this and cancel out of the analysis. And let's go to analyses and ordering by plot. And we'll move group over and we'll move time over. And let's get the bubble plot. And let's plot the frequencies, select OK. We're taking the text output window. It just tells us that it's created a bubble plot based on these orderings. So we'll go to the graphics output window. I can see it here. I can just click that and that would bring it to the front, or I can use the tab here. And here we have a bubble plot, which is kind of like two frequency histograms next to each other. Now, instead of bars, we have these bubbles to indicate greater frequency. So a larger bubble indicates a greater frequency than a smaller bubble. And here we actually have the frequencies within the bubble. So we can see there are two people here, 1, 2, and so forth. Now, just eyeballing this, you can see that the experimental individuals, sure enough, scored lower typically than the control individuals. So you can see the range over here, 6 to 27. So a picture is worth 1,000 words, and one of the really like mottos in observational order modeling is to look at your data as frequently as possible. And so here we can use this bubble plot to eyeball it and create our expected ordinal pattern then for the analysis. But now, you still though want to use descriptive stats. We've already seen the medians, but let's say you want to use the means instead. Well, then you can go to analyses, descriptive stats, orderings, put time over there, and then put group as a separate by. And then here we get mean, median, and mode, our standard indices of central tendency. Select OK. And here we see the actual median. So 8 for the experimental, 15 for the control. So that, again, is the expected ordinal pattern, experimental less than control. And if we want to use the mean instead, that corroborates that. 8.86 is less than 16. Now, interestingly, the modes are reversed here, 12 to 11. But as you know, modes can be rather sensitive, especially with these small data sets. So if you wanted to use the descriptive stats, the means or the medians, you can do so. And then we can go to the analysis then, ordinal analysis, crossed orderings, move time over, group over. And now let's say based on that bubble plot, we're expecting the experimental less than the control. So we're off and running then with the analysis. Get our randomization test. We can turn off the pairwise comparisons because we only have two groups in this analysis. Select OK. And there we are back to our 87.5 PCC that we've seen in previous videos. Chance value for this run through the data is 0.01. So overall, impressive results. So if you do not have a predicted a priori ordinal pattern, you can still run the analysis using the bubble plot is what I'd recommend, or you can use the medians or the means to help you set up that ordinal pattern.